to continue with the orthogonalization process, let me consider the following specialization. So here I have a linearly independent set of three vectors. And on the other side, I have three vectors, but I haven't explained anything about those yet. I will do so in a moment. So by the time that I set W1 to be U1, I'm making sure that the following happens. So explanation here. I have that the span of U1 is exactly the same as the span of the set that contains W1. Now, what I have here is essentially the picture that we had in the previous example, where we take away a certain projection. And by doing so, we guarantee the following. The span of U1 and U2 is the same as the span of W1 and W2. So now you can imagine what's going to happen here. Well, I'm moving to dimension 3. So now I have two projections to consider. One onto W1 and another one onto W2. But once I do that, well, I guarantee that by introducing W3, I get that the span of U1, U2, and U3 is equal to the span of W1, W2, and W3. So as we continue with this process, all that we have to do is to remove more projections. That is exactly what the Schmidt orthogonalization process is about. You start with the same vector, as you can see here, and you remove the associated projections as you progress in the process.